There's a substance that costs less than $2, fits in the palm of your hand, and reduces engine wear by over 90%. Not slows it down, not delays it, eliminates it at the molecular level. One application to your engine oil and the internal metal surfaces of your motor become nearly friction-free for the next 50,000 miles. NASA used it on the moving parts of the Mars Rover. The Soviet military applied it to tank engines during the Cold War. Deep-sea drilling equipment coated in this compound operates under pressures that would crush a submarine without a single mechanical failure for years. It requires no special tools, no mechanical skill, and no garage. You pour it into your oil like a coffee creamer. And yet you've never seen it on the shelf at your auto parts store. You have never heard a dealership mention it. You have never read about it in any owner's manual produced in the last 7 decades. This is not an oversight. This is the story of tungsten disulfide, the anti-friction compound that outlasts engines and represents an existential threat to profitable industries. Welcome to Fixvival. If this knowledge matters to you, the subscribe button and the bell are the only way to make sure it survives. Here is where we open the vaults, the industry locked shut. Let me take you back to where this all begins. The year is 1953, and the Cold War is not just a political contest. It is an engineering arms race measured in metal, fuel, and mechanical endurance. Both the United States and the Soviet Union understand that the nation whose machines last longer wins. Tanks that seize in the field, aircraft engines that fail over hostile territory, truck fleets that break down. These are not inconveniences. They are strategic catastrophes. Inside a classified research laboratory at the National Advisory Committee for Aeronautics, the organization that would later become NASA, Dr. Robert Holmberg is staring at a problem that has plagued mechanical engineers since the first steam engine turned its first piston: friction. Specifically, the microscopic destruction that happens every single time two metal surfaces slide against each other under pressure and heat. Holmberg and his team are testing solid lubricants, compounds that reduce friction by bonding to the metal and creating a permanent low-friction molecular layer. They test graphite, they test molybdenum disulfide, and then they test a compound extracted from the mineral tungstenite, a dark gray crystalline powder called WS2. What they document changes everything. Tungsten disulfide does not simply reduce friction, it restructures the metal surface itself. The compound has a layered molecular architecture, flat hexagonal plates stacked like a deck of cards at the nanometer scale. When applied to metal under pressure and heat, these plates slide against each other with virtually zero resistance. The coefficient of friction measured in Holmberg's 1953 tests was 0.03. To understand what that means, consider synthetic motor oil achieves 0.1. Tungsten disulfide is over 3 times more slippery than the finest oil money can buy. And unlike liquid oil, it does not burn off. It bonds to the metal permanently and stays there. Holmberg files his findings in a classified technical report for the NACA. But the compound is not alone in its history. Long before Holmberg, there were other clues scattered across time and continents. In 1778, a Swedish chemist named Carl Wilhelm Scheele was analyzing a dark gray ore found in the mountains of central Sweden. Scheele noted in his laboratory journals that any iron tool coated with crushed molybdenite powder showed dramatically reduced surface wear after extended use. Meanwhile, in the mines of the Ural Mountains in Tsarist Russia, workers had developed a tradition. Before inserting the iron shaft of a mining drill, they packed the joint with a dark gray powder scraped from certain local rocks. They called it fatstone. The knowledge lived in the hands of workers, and it stayed there, undocumented and unmarketed, for over a century. Now, let me show you exactly why this compound does what nothing else can. Because the science is as elegant as anything in engineering. Every engine in every vehicle ever manufactured operates on the same brutal physics. Metal slides against metal. The crankshaft spins against its bearings. The pistons drag against the cylinder walls. The camshaft rotates against its lobes. Every contact point is experiencing microscopic destruction every second the engine runs. Even with fine synthetic motor oil, there are moments like cold starts or high-load conditions where the oil film thins and metal touches metal directly. Each of those contact events removes a microscopic layer of material. The technical term is adhesive wear, measured in nanometers per cycle. Tungsten disulfide stops this process through tribofilm formation. WS2 particles are suspended in your engine oil and circulated under pressure and heat. Under the pressure of contact zones, the hexagonal WS2 plates crack open and bond directly to the metal surface at the atomic level. The result is a continuous solid lubricant film, 3 to 7 nanometers thick, covering every bearing surface and cylinder wall in the entire engine. This film cannot be wiped away by heat. It does not thin out under load. It is a permanent structural modification of the metal surface itself. The friction coefficient is 0.03. By comparison, ice on ice measures 0.05 to 0.1. A WS2 treated engine bearing is more slippery than ice. A study at the University of Leeds measured a 94% reduction in material loss versus untreated steel. That is not an incremental improvement. That is a categorical transformation of engine longevity, protecting your engine with science that operates at the limit of physics. Now here is where the story takes a very dark turn. And I need you to follow the numbers carefully because what they reveal is not an accident. The global automotive aftermarket, the industry that sells you replacement parts, fluids, filters, and services, generates over $400 billion in annual revenue. The largest single category inside that number is drivetrain components, engines, transmissions, and the parts that wear out inside them. An internal combustion engine is not engineered to last forever. It is engineered to last long enough to clear the warranty period, long enough that the failure feels like natural aging rather than designed obsolescence. The average passenger vehicle engine in the United States requires a significant mechanical intervention somewhere between 150,000 and 200,000 miles. The auto industry has built an entire economic ecosystem around that number. Parts manufacturers, machine shops, dealership service centers, and oil change franchises. Now imagine a $2 compound that extends that interval to 500,000 miles or beyond. Imagine a substance that reduces internal engine wear by 94%. The business model does not adjust. The business model collapses. By 1955, word of Holmberg's NACA findings had begun to circulate in certain industrial circles. The compound was being tested in aerospace applications and military hardware. But before WS2 could reach the commercial market, something interesting happened. The major petroleum companies redirected the conversation, not through suppression, through complexity. In 1957, the Society of Automotive Engineers published its first standardized grading system for motor oil. The system still printed on every bottle today. This system measured viscosity, how thick the oil was. What it did not measure was anti-wear performance at the metal contact level. Through the 1960s and 1970s, major oil companies invested hundreds of millions developing synthetic base stocks, detergent packages, and viscosity modifiers. A naturally occurring mineral compound that cost $2 per treatment could not generate quarterly earnings reports. The industry simply never included it. Every major automotive manufacturer published oil specifications that mentioned viscosity and oxidation. None of them mentioned solid lubricant additives. Every oil change reminder, the sticker on your windshield, was calibrated to the degradation rate of oil-only lubrication. With WS2 protecting your bearing surfaces, the wear that the oil change was supposed to prevent has already been eliminated by the molecular film. But the knowledge did not disappear. It went underground, into the hands of machinists, motorsport engineers, and industrial maintenance specialists who could not afford to ignore results. In the late 1990s, a network of high-mileage vehicle enthusiasts in Germany began documenting WS2 treatments on diesel engines. Several members drove Volkswagen and Mercedes diesel vehicles past 600,000 kilometers, approximately 375,000 miles, with no engine rebuild. Compression tests on these engines at high mileage showed values within 5% of factory specification. The forums documenting these results were published in German automotive hobbyist publications, and later archived online. A metallurgical analysis in Stuttgart found WS2 tribofilm deposits still intact on the cylinder walls of an engine with 580,000 kilometers. In 2001, a mining company in northern Canada began treating its fleet of Caterpillar diesel engines with nano WS2 additive for maintenance reduction. Internal results shared in Calgary showed a 67% reduction in unscheduled engine maintenance events over a 3-year period. Engine overhaul intervals extended from 8,000 hours to over 14,000 hours. The compound that Holmberg documented in 1953 was, 50 years later, saving a mining company millions of dollars per year. NASA's Jet Propulsion Laboratory continued using WS2 as a standard coating in spacecraft where oil-based lubrication is impossible in the vacuum of space. The Mars Science Laboratory, the Curiosity rover, uses WS2-coated wheel bearings and drive mechanism components. The compound operates in temperature extremes from negative 125 to positive 20 degrees Celsius on the Martian surface. Under constant radiation exposure, it continues to perform after more than a decade of operation on another planet. If WS2 can keep a Mars rover's wheels turning, it can keep your car engine running past 500,000 miles on a paved road. Here is exactly what to do, and it is almost insultingly straightforward. Source nanoparticle tungsten disulfide powder from any industrial chemical supplier or online bulk retailer. You're looking for WS2 powder with a particle size between 60 and 120 nanometers. A 10-gram quantity costs between $1 and $3 depending on source and typically treats a standard vehicle for 50,000 miles or more. Some suppliers offer pre-suspended WS2 in a light carrier oil, which makes application even simpler. Do your oil change as normal. Use whatever oil your engine requires. Conventional, synthetic, blend, it does not matter. The WS2 functions independently of the oil's organic chemistry. Once you have added your fresh oil, measure 2 to 3 grams of WS2 powder. per 4-liter oil capacity. Add it directly to the oil fill cap opening. Start the engine and let it run at idle for 10 to 15 minutes. This initial circulation period allows the nanoparticles to migrate through the oil passages and begin depositing on metal contact surfaces. During this period, you may notice a slight reduction in engine noise. This is the tribofilm beginning to form on the bearing surfaces. The friction reduction is measurable with a sensitive ammeter monitoring the alternator load. The engine is working less hard. Over the first 500 miles following treatment, the tribofilm reaches full coverage. After that point, the film is self-sustaining. When you perform subsequent oil changes, add a maintenance dose of 1 gram per 4 liters to replenish any particles lost. The film itself remains on the metal. You are simply ensuring fresh particles are available for any surface microdamage repair. For a vehicle that already has significant engine wear, use a slightly higher initial dose, 4 grams per 4 liters, and perform 2 consecutive oil change cycles with maintenance doses to allow the film to fully populate worn surface irregularities. Owners of high-mileage vehicles frequently report compression improvements of 5 to 12% following WS2 treatment. For motorcycles with oil-bathed clutches, consult your model's tolerance before use, as WS2's properties can affect wet clutch engagement. For diesel, turbocharged, and naturally aspirated engines of any displacement, the compound is universally compatible. Total cost for initial treatment, $2 to $4. Total time required, the same 20 minutes your oil change already takes. Compare that to an engine rebuild costing thousands. Compare it to the cumulative cost of 20 years of oil changes designed around wear. This compound eliminates that wear rate on the first application. Take control of your engine's longevity today. Every civilization that worked metal understood that friction was the enemy of endurance. Roman engineers packed lead and tallow into chariot wheel hubs to keep them turning through the campaigns of empire. Medieval millwrights carved wooden bearings with whale oil to keep their grinding stones producing flour for generations. Russian miners packed dark gray powder into drill shafts because experience had taught them that the mountain gave them something that nothing else provided. A scientist in 1953 measured what they had always known and documented it in numbers precise enough to build spacecraft. And then the industry that was built around the problem quietly made sure the solution never found its way to the shelf. The knowledge did not disappear. It waited in classified NACA reports and maintenance logs of mining companies in northern Canada. It waited in the wheel bearings of a rover still turning on a red planet 225 million kilometers away. Chemistry does not negotiate with market share. A molecular film 5 nanometers thick does not care what the quarterly earnings forecast says. The metal it protects will outlast every argument for why it should not exist. Your engine is wearing right now. Every cold start, every red light idle, every highway mile is removing material that cannot be replaced. Or it does not have to be. $2, 1 treatment. The same compound trusted to keep a machine running on another world can keep yours running past every number the industry told you. Subscribe and share this with someone who still believes that engine wear is inevitable